Hey everyone, in this mini lecture we're going to find the distance between 2 points in a coordinate system. So the 2 points for us will be 3, 1. So I'll go ahead and draw that point. 3, 1 is right there, 3 in the x direction, 1 in the y direction. And the other point will be 6, 5. So we'll go to 6 in the x direction and then up 5. So 6, 5. Alright, so 3, 1 and 6, 5. The next thing I'm going to do is just connect those dots. Okay, so what we're trying to do is find the distance of that line from 3, 1 to 6, 5. Well, you see, it's in a diagonal, so there's no real way for us to count off the distance just by looking at it. We could only do that if it were a vertical line or a horizontal line, right? Because all of the tick marks, the numbers are on where the grid crosses and intersects. So what we're going to have to do is extend a vertical and then extend a horizontal. So let's do that. So if we drop a vertical down to right there and a horizontal right to where they meet, now we can count this side and say it's 1, 2, 3, 4, right? That side is 4 units. And we can count this side as well, that bottom side. So that bottom side looks like it's going from 3 to 6. So that bottom side is about 3 units. 3 units. So therefore we know the legs of the triangle. We have c squared equals a squared plus b squared. We know the legs of the triangle, the a and the b. So we know that one leg is 3, so that'll be squared. The other leg is 4, and that's squared. And we're looking to find C. C is the hypotenuse, right? C is the longest side, the side that's opposite of the right triangle. You know that there's a right triangle there, so that C is that hypotenuse. We're going to find what C is. First, it's C squared is equal to 3 squared, which is 9, plus 4 squared, which is 16. So c squared is equal to 9 plus 16 is 25. And now we just use the square root property, taking the square root of both sides. When we square something squared, square root, we're left with that value c. That's what we wanted the whole time, to get that c. And the square root of 25 is 5. So the distance between 3, 1 and 6, 5, that green line up there, is 5 units. 5 units. Okay, so let's try another one. Let's say we were looking at the points. One point can be 1, 4. That's one ordered pair. The other ordered pair, let's do 7, let's go with a negative value this time. 7, negative 3. Right, so 1, 4, that ordered pair, 1 in the x direction, 4 in the y direction. Right there, it's 1, 4. And then our other ordered pair is 7, negative 3. 7 in the x direction, negative 3 in the y direction is right there. So 7, negative 3 is what I'll label this one, and this one is 1, 4. Right, so I'm just going to go ahead and connect them with a different color. Let's maybe use a green. So I'm just trying to find that distance. So to find any diagonal distance, you cannot just look at it and just try to count off squares or whatever have you. So what we're going to do, we're going to drop a vertical line straight down. That'll match up with the horizontal line coming from the other point. And now we can easily see, okay, this is, let's see, 1, 2, 3, 4, 5, 6 units. So that's 6 units. And then we can look at this and say we're going 1, 2, 3, 4, 5, 6, 7. This is 7 units. 7 units right there. Okay, so we have c squared equals a squared plus b squared. So the c is the hypotenuse. That's the c. That's what we're trying to find. But now we have c squared equals a squared plus b squared from the Pythagorean theorem. Our a and b are the legs, the 7 and the 6. So we'll have 6 squared plus 7 squared is equal to the c squared. So 6 squared is 36 plus 7 squared is 49. Alright, so c squared is 36 plus the 49 is 85. And at that point, we're using the square root property, so we're squaring both sides. So when you square a square root, they cancel, the radical symbol and the exponent cancel, so you're left with c. 85 isn't a perfect square root like the last example. So for something like this, it's okay to just put it in your calculator, take the square root of 85, and we get 9.219. Maybe if it said round to the nearest hundredth place, then we would say 9.22. So that green line from 1, 4 to 7, -3 is 9.22 units long. Alright, so in this example, we're going to look at 2 points. The first point will be -4, 5. That'll be the first order pair. Let me go ahead and just plot that point. -4 in the x direction and 5. So this will be in the second quadrant, quadrant 2. -4, +5. Okay. Alright, and the next point, I want to look at the point, let's say 4 and -4. So 4, -4. So 4 in the x direction and -4 is going to be right there. So that's in the fourth quadrant. Alright, so what I'm going to do now is just connect those points, because the question will just say basically what's the distance between those 2 points. And if I had a straight edge ruler, then this line would be much better. Let's try that again. So always use a straight edge when doing your work. Alright, that's a little bit better. So we're trying to find this distance in green of that line, -4, 5 to the other point 4, -4. Alright, so to do that, we're going to use Pythagorean Theorem, but of course that only works with a right triangle, so we're going to create a right triangle. So we create a right triangle just by dropping a vertical line straight down to where it meets up with the horizontal line coming from the other point. So now you can see that this is a right triangle. If that's a right triangle, then the side opposite, that side, that green side, that side is the side C. The other sides will be our A and our B, right? The 2 legs are our A and our B. So I'll label that A and then B. A and then B. Alright, so we can now just figure out how long they are. Alright, so just count from -4, 5 going down. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So A is equal to 9. And we can do the same thing for B. So we can say 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter which direction we go. So that's 8 units. So B is equal to 8. So now we know the lengths of the 2 legs, and now we can go ahead, because we know it's a right triangle, and just apply the Pythagorean theorem. C squared equals a squared plus b squared. Well, We're looking for that C. So now we can say to ourselves, let's input the A and the B. The A is 9 squared plus the B is the 8 squared. So 9 and 8 are our A and B. The Pythagorean theorem says to square them both. So C squared equals 81 plus 64. So C squared is whatever 81 plus 64 is. Punching that in, you can get 145. And now we're just going to say C squared equals 145, and I want to show this step. The last step is to use the square root property. When you square a square root, you cancel and you're left with what's underneath and the square root of 145. Again, that's not a perfect square like the first problem we had, so we could go ahead and use a calculator if your instructor wants you to find the decimal approximation. So I get 12.041, so maybe let's say they said to round the distance to 2 decimal places, so we'll say it's 12.04. 12.04. So the length of that green line is 12.04 units.